Assalamualaikum warahmatullahi wabarakatuh, and we are from group 4 and we will present you about falling ball viscometer experiment. So our first step is to measure the diameter of the ball, stainless steel ball, and we use that using vernier, and we need to weight the ball because we need to find the density of the ball. So first we need to switch on the main power, switch on the main switch, switch on the super thermostatic oil valve, and we need to switch on opening the valve. First, check the sensor. Yes, the sensor is on. After that, pour 250 milliliter of silicone oil to the tube. Switch on the super thermostatic oil bath, turn on the heat, and turn on the pump.
Alright, so next, once the inspection has been done, we need to fill up the heating spirator with the thermal oil up to 80%. And then we need to make sure the 3-point valve is pointed at point 1 and point 2 to allow the circulation from the heating spirator to the inner jacket. And then we turn on the heat switch and then set the desired temperature. Then we turn on the pump switch to allow the flow from the heating spirator to the inner jacket. Alright, next, once the temperature needed has been reached, so place the stainless steel ball at the motorized ball valve. Then next, key in the experiment data. Alright, and then after we key in all the experiment data, which is the ball size is 12 mm, the type of the ball is stainless steel, and the temperature needed is 27, and then switch on the motorized gate. Then take the reading from the timer and key in for the test one. So we need to take at least 3 readings to get the average time reading for the time taken falling ball viscometer. Alright, so take the calculate average reading for the time taken, and then key in all the results into the result table.
Okay, once the observation was taken, we need to open the manual ball valve to discharge the ball and the liquid. And then after it's done, we need to repeat the experiment with a different type of ball, which is iron, and also take a different, at least four different reading of temperature for each ball. And then once the experiment is done, we need to switch the heat, the pump, the power here, and then both of these switch at the main component. This one, close the valve, and then off the main switch. And lastly, we need to close the main power here, switch off the main power.
So for the experimental data for this experiment, as you can see here from table 1, table 1 shows the type of ball that we use, which is the stainless steel and the iron, and we have the density rho b here, the diameter, and constant K. For the table 2, falling ball viscometer calculate the average time at 4 different temperatures, which is 25, 40, 55, and 70. So how do we calculate the dynamic viscosity? This is the formula mu Kt rho b minus with rho s. So let's focus to calculate the dynamic viscosity at 25 degrees C for the stainless steel sphere ball. We have the K for the stainless steel here is 0.09, and the T 25 degrees Celsius 4.378, and then the rho B here, this one, and then the rho S, this one. We just substitute all the data in here, and then we will get 3.028. Same calculation for the iron sphere ball, but we need to use the table 3 data. To help you more understand, this is how we calculate the dynamic viscosity. This is the example for the iron and stainless steel dynamic viscosity at 25 degrees C. So as you can see from the data of this result, the stainless steel is lighter in density due to lower carbon content. This means that with higher density, it should indicate in lower viscosity. So here the graph, the temperature versus the dynamic viscosity, also can conclude that the dynamic viscosity will decrease with the increasing of temperature. I think that's all from group 4. Thank you.